In this video, we're going to do more examples where we construct truth tables that involve the operators not, and or. So let's construct truth tables for the following compound propositions. Part A asks us to do it for not P or Q. Alrighty, so I want to begin by writing P and Q on the left-hand side of two vertical bars. Those are sort of the basic or the simple propositions that go into this. And then on the right-hand side, I'm going to slowly build this one up. So I notice I have a not P. So let's write not P. And then I also have a not P or Q. So I'm going to slowly build it up like this. And I'll separate them with just one vertical line. So I want to first point out, well, that this means not P in parentheses or Q. It does not mean the negation in front of a parentheses P or Q. If I had meant to say this, I would have put a parentheses around the P or Q portion. Alrighty, so on the left-hand side of these two vertical bars, I write down all the truth values of P and Q. So there's two choices for P's truth values, true or false. Two choices for Q's truth values, true or false. So that'll multiply to 4. So I know there's going to be 4 rows here. And as we've seen before, we start off with Q, we alternate true, false, true, false. And then with P, we alternate double trues and double falses. So double true, double falses. And now we've listed all the combinations that we could have of those two. So first, let's write down the truth values now of not P. Well, when P is true like this, not P would be false. So it's false here, false here. And then when P is false, not P would be true. So this is true, this is true. So now we need to combine the not P column with the Q column to get the truth values for not P or Q. So not P or Q is going to be true when at least one of those two things is true. So here I have a false or true, which is true. And then I have a false or false, which is false. True or true, which is true. And then true or false, which is true. And this is my full truth table. Alrighty, let's look at another example. Part B. Part B says P or not P. Okay, so now there's sort of one basic proposition that makes up this whole thing, which is P. So I'm going to write that to the left of two vertical bars. And there's just two choices for its truth values. It could be true or it could be false. And on the right-hand side, I'm going to slowly build up this proposition. So I'm going to put a column for not P. And then I will put a column for P or not P. Okay, so not P has the opposite values of P. It will be false and then true. And then when I combine those and do P or not P, I'll first have a true or false, which is true. And then I'll have a false or true, which is true. Because to make an or statement like this true, you just need at least one of these two parts to be true. Alrighty, so in this truth table, all the outputs ended up being true, and that has a special name. So a proposition whose outputs are all true is called a tautology. Alrighty, so let's do another example. In this one, we have the statement P and Q in parentheses, and then in parentheses not P and not Q. So for this one, I'm going to put P and Q on the left-hand side of the two vertical bars, because those are the two basic propositions that are making up this whole compound proposition. And let's write down their truth values. So for Q, I'll alternate true, false, and then for P's, it'll be double trues, then double falses. And then I'll slowly build up on the right-hand side, this compound proposition. So let's put P and Q. Let's put a not P, a not Q, and then a not P and not Q. So we're going to build that one up. And I think I need one more, actually. After that, then I got to put it together. Then I'll do P and Q and not P and not Q. Running out of room, so I got to try to fit it in here. Alrighty, so I just shifted it over to give myself some more room. So now let's fill this out. So for P and Q, the only way this is going to be true is if P and Q are both true. So this is true, false, false, false. Not P is going to be the opposite of P. So it'll be false, false, true, true. Not Q is going to be the opposite of Q. So this one's going to be false, true, false, true. And now let's combine the not P and the not Q. So these two columns. So I'm ANDing both of them, combining them with an AND. So to make that AND statement true, both of these two columns need to be true. And that only happens in the bottom row, true and true. So this is true over here. But then everything above that is going to be false. False, false, false. So now in the last column, I need to combine the P and Q column with the not P and not Q column. So I'm going to combine them with an AND operator. So I'm looking at this column, looking at this column. For this whole AND statement to be true, I need a true in both of these columns. But unfortunately, in all these rows, I don't see that. So this is just going to be false, 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 false. So this type of proposition has a special name where the outputs are always false. So let's write that down. A proposition whose outputs are all false is called a contradiction. And on an intuitive level, I can sort of see that from looking at this. Because this is, the first part is saying P and Q, but then right after that it says and not P and not Q. So that doesn't make sense for all of that to be able to occur simultaneously. But of course, we were able to verify that rigorously with this truth table. So let's do one more, part D, where I have P and Q in parentheses, or not R. So there's three basic propositions that go up into making this one. There is a P, a Q, and an R. So I'm going to put all of those on the left-hand side of two vertical lines. Left-hand side, two vertical lines, okay. So I'm going to get this one started and then give you a chance to fill out the rest of the table. So because there's three of these, there's two choices for P's truth values, times two choices for Q's truth values, times two choices for R's truth values. All of those could be either be true or false. And when we multiply this, we get 8. So I know there's going to be 8 total rows. So starting with the last one, let's alternate true, false, true, false, true, false, true, false, and then go to Q and then do double trues, double falses, double trues, double falses, double trues, double falses. And then we go to P and now we do 4 trues and then 4 falses, 4 trues, and then 4 falses, 4 falses. And now we got the left-hand side set up. Alrighty, so from here, I want you to pause the video for 2 minutes and see if you can fill out the columns that we need on the right-hand side. 4, 3, 2, 1, pause it. Pause it for 2 minutes, see if you can finish up this truth table. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 2 minutes. Let's finish it out. Okay, so I need to put P and Q. I'll need a column for not R. And then I'll have to combine those and have P and Q or not R. So let's separate those with just single bars. So for P and Q, for this to be true, I need both P and Q to be true. So that happens in the top row and the second row, but I think that's it. So the rest of these are false. And the rest of these, at least one of P or Q ends up being false, which makes the AND statement false. Okay, not R is going to be the opposite of R. So this will be false, true, false, true, false, true, false, true. And now we combine the P and Q column with the not R column. I'm going to connect them with the OR operator. So this is going to be true if at least one of these two things is true. So with true and then a false, at least one of them is definitely true, so that makes it true. And the next row, both of them are true, so that makes the OR statement definitely true. And if I keep going like that, let me just fill out all the trues first. The fourth row is true, the fifth row is true, and the last row is true. But in all the other rows, both of those statements were false, and that would make the OR statement false. So this is false, false, false. And that is my truth table right there. So in terms of our goals for this section, we finished our last goal, which is to practice constructing truth tables of compound propositions.